Okay, so let us continue where we ended on the science, which is the chemistry part, GC 205. So ended on question 10. Okay, so we are going to move on to question number 11. Okay, and what is question number 11 telling us? It says calcium carbonate thermally decomposes to form calcium oxide and and carbon dioxide. According to this equation, you can see it properly, right? Can you see something strange here? Have you seen how the state symbols are being written? You see, they're not being written like the way they're writing a 3. No, they're being written in the same manner the symbols are being written here. So don't write, for example, if I say calcium, you come and write it as a subscript, you say solid. No longer this, but instead if you write calcium, just straight open and close and write the state symbol all together. Those are some of the things that you need to know in case your teacher didn't tell you. Now it says 8 grams of calcium was strongly heated and 3.4 grams of calcium oxide remained in the crucible. What was the percentage yield of calcium oxide? This guy here, not this one, but they're looking for the percentage yield of this friend here. Now, the only mass of calcium oxide that we have is the 3.4. How do we find the percentage yield? So you understand that percentage yield, all right, will always be equal to this mass here that remained, okay, remaining mass, over the initial mass. So what is our initial mass? We need to calculate it. That mass is actually we have the actual yield and we also have the theoretical yield. So that's the difference. So the actual one is our initial mass. Then the yield is what we produce later on. So we can use mass ratio. We can use mass ratio. Put calcium oxide here, calcium carbonate here, and put calcium oxide there. Look at the mass. It is 8 for calcium carbonate. Do you know the mass for this one? No, just put an X there. Then which other mass are we comparing? We're going to compare the relative molecular masses. You know how to find the relative molecular masses. For calcium, it's 40. Carbon is 12. Oxygen is 16 by 3, which will give you 100. Come for calcium oxide. Calcium is 40. Oxygen 16, giving you 56. If there were numbers here, whatever that number that you find here, you could have just multiplied direct because the equation is already balanced. Then, like that, then you cross multiply. Meaning 100x is equal to 8 by 56 over 100 to give you 75. Just a minute. What am I? Not 75, 4.48. You get 4.48 grams. So this is the initial mass, or in short, the theoretical mass, the one which is given. So the remaining mass is 3.4, and the theoretical one is 4.48. So you should be able to get 76 when you round off. Hydrogen peroxide solution decomposes very slowly at room temperature to produce oxygen and water. You know this equation of hydrogen peroxide, right? This. Now they're saying this reaction is actually very slow. Apart from increasing the temperature, suggests the best way the reaction can be speeded up. We know that increasing the temperature speeds up the rate of chemical reaction, but that can also affect if there are enzymes involved. Increasing concentration, increasing light intensity, increasing the surface area using a suitable catalyst. Well, all these are not really important at this particular time because this is a reaction and the reaction is taking place at room temperature. That's why the keyword is. This is why I say Some of you just write, you just know that it's room temperature, but what does that really mean? What does that really mean? Wait, room temperature and pressure, most of these conditions are stable. So using a catalyst would be the best idea here. Simple as that. The diagram shows the electronic structure of an ion of element L. To which group and period of the periodic table does element L belong? Well, if you want to know the group, just look at the charge. So it's group 3 in Roman numerals, by the way. If you want to know the period, remember that this plus 3, it means that there is another third shell containing 3 electrons in the outer shell. This is why they didn't even include it. To see if you know. But because you swatted the stuff, you failed this question. They only showed 2 shells here. But without knowing that the plus 3 here, the plus 3 is also showing that it's another shell. Because plus 3 means we are losing electrons. How many? 3 of them. Meaning there was another shell here having 3 electrons if I erase it like that. But to look smart, I can't write the third shell. I'll ignore it. I'll just write the charge. You'll see. So meaning there was another shell, meaning number of shells tells you the period. Period 3. Which is the electronic configuration of a noble gas used to provide an inert atmosphere in welding? So if you even go to the periodic table, you should be able to know. So 2, 8, 10 plus 8, 18. What? Argon. Let's check together. Yes, it's argon. Argon is the one which is used to provide the inert atmosphere in welding. You see? So what I keep on saying. It's not always that they're going to say, write the configuration for argon. They know you can do it. Well, what if I put it in the form of, real life application, then to say, can you do it? People are suffering. And this is a state where I say, I don't teach past papers. Past papers are just there for revision. But I'll teach you concepts so that you know what you really need to know. Metal Y was added to iron sulfate solution and the solution changed from green to colorless. Green to colorless. You might wonder, where this coming from? Hey, what is the identity of metal Y? Magnesium, silver, gold, copper. The only thing this is the equation happening. So this friend of ours is green in color. That's what they're saying. It's green. Then the only metal which can change this to colorless is magnesium. The diagram shows the main stages in the manufacture of ammonia-based fertilizer. So nitrogen, hydrogen, separation, then fertilizer manufacture. Iron as a catalyst, 500 degrees Celsius, pressure 200 atm. Atm means atmospheres. What is happening in the process labeled Y? This process from separation back. So sometimes it happens to say, during separation here, some of the things remain, like more hydrogen remain and more nitrogen remain. And these guys are feeded back into the reaction chamber to produce more fertilizer. So based on what we've said, unreacted hydrogen and nitrogen are recycled back. It's just recycling. Methane is reacted with steam in the process of nickel as a catalyst to produce gas T and carbon dioxide. What is the suitable method of collection of gas T and the liaison? Now here's the thing. Methane reacts with steam. So this is methane. React with steam. It gives us gas T plus carbon dioxide. What is a suitable method of collecting gas T, and the reason? Do you know the best way to know the method of collection and the reason? Is first to know gas T. Go back to organic chemistry. When methane reacts with steam, what other gas is produced apart from carbon dioxide? It's actually hydrogen. Now that you know that it's hydrogen, what method of separation or correction or collection do we use, all right, for hydrogen? And why? We know that hydrogen is less dense than air. Hydrogen is less dense than air. We know. So what do we use? We use upward delivery, not downward, but upward. When a gas is less dense than air, we use the upward. 18. Pollutant gases are released by the bacterial decay of vegetable matter. Which gas is mainly sourced from decay of vegetable matter? If your answer was methane, you are correct. Butene can undergo addition reaction with steam to form compound R. What is the name of compound R? Now, you get an alcohol, you add the steam or water, you form an alcohol. And an alcohol always get the name from the methane name. Since this one is butane, our alcohol will end with that, and you add butyl. In fact, an alcohol end with ano, then you get the but you add there to give you butano. Question 20. Polymers are made using monomers, which is true. The following are structures of some monomers: W, X, Y, and Z. Identify the correct set of monomers that form a polyamide linkage. Well, polyamide linkage is mainly for proteins and nylon. So the question is, identify that linkage. Of course, you expect to be hydrogen, carbon, and oxygen. Yeah, I think so. All right. Well. Look at Y. Well, here, okay, looks fine. But for us to have this type of arrangement here, I'll give an example. To form nylon, all right, we have two monomers, the dicarboxylic acid and amine. So we have this type of compound, okay. We also have a dicarboxylic acid, like this, okay. So you will see that you need an alcohol. This is an alcohol, so this is an acid, and this is an amine. You need these two for you to have an amide linkage. So where do we have an acid here? Okay, this is not an acid, just an acid must have a double bond somewhere on oxygen carbon, like this one has. This one, no. After identifying an acid, which is this one, identify an amine. An amine must have H and H. You can see it there and there. So these two will give us a polyamide linkage. Simple as that. So now that we're done with section A, we shall move to section B next time we meet, and make sure to follow and share and subscribe.